This question asks, which of the following molecules will not act as an electrophile in the presence of a nucleophile? All right, so there's a couple definitions that we need to consider. One, what's an electrophile? And two, what's a nucleophile? Okay, electrophiles are electron deficient, so they want to accept electrons from another molecule. Nucleophiles are electron dense, so they want to meet up with an electrophile to share their electron density. All right, so let's kind of write that out. We'll say electron deficient. And then over here, this is electron dense. And the key thing we're looking for here is which will not act as an electrophile. So let's look at our answer choices. Okay, in A, we have BH3. BH3 looks like this when we draw it out. And BH3 is similar to a carbocation in that it has an empty p orbital. So it can accept electrons. So that makes it something that can act as an electrophile. Next up, we have a carbocation, a tertiary carbocation, because it has 3 R groups. Okay, also has that empty p orbital that can accept electrons. Okay, C is a propyl bromide, and we know that this is electronegative and pulling electron density away from that alpha carbon, making it electrophilic. Okay, and then in D, we have methylthiol, CH3SH. Okay, and it's important to draw in those lone pairs for that sulfur atom. The reason why is because typically thiols and thiolates, the negatively charged version of a thiol, are going to act as nucleophiles. All right, so why is that? Because the sulfur atom is really large, and in the presence of an electrophile, it can get its charges kind of all added up on one side. And so that can make it be a little bit more electron dense on one side, and so it'll act as a nucleophile in the presence of an electrophile. Sulfur is also kind of analogous to oxygen, which is right above it on the periodic table. And so, however oxygen typically acts, sulfur will act similarly. And so we know that alcohols and waters can act as nucleophiles because they have lone pairs. Same idea with sulfur. It has 2 lone pairs, and so it's more electron dense and can act as a nucleophile in this case. So we said that BH3 was an electrophile, the carbocation was an electrophile, the alkyl halide was an electrophile, but the thiol is not. Right? So the answer to this question is D.